Hi, this is a video about this magnetic formation as well as some others coming up later in the video. And you can't really tell from this. It looks like it's a cross from this. But let me just pull away. You can't really tell, but let me do it again. You could kind of tell. Now you could kind of really notice something. Yeah. This geometry shows up. The Japanese call this the manji. Other cultures have other names for it. They just leave it as that. And at this distance, like an inch and a half, you kind of see the cross. And then closer you get, it gets torqued, and you get this. And at the plane, central plane of this, you should be able to see, actually you should be able to see a circle and a cross. So the dielectric plane, so the magnet over here, it's right there. And there's a 45-degree torsion between these right in the center. This plane over here, like right there, right there, that plane. So this will be more circular at the periphery and more like a cross in the center of the circle, right? Can we visualize that? I don't know if you can't, but let me just show you this part a little bit. I don't know if you can see or not, but let me just try for a little bit. And yeah, that's gonna be as good as it gets, at least from this angle, in relation to the lighting that I have. And let's see what happens when I put these together. But before I do that, gotta show you guys that these are the same. I accidentally put them together. Oh no. Okay, I pulled them apart. Okay. Oh boy. I had to pause the video twice. This is the second time. Well, I put them together like this, so you could see for yourself polarity. Alright, now since we have established that the center part of this is actually like this, if you could visualize that, at least from here, it is a circle with the cross, but so over here, here, and here, you have this. this is very important because this is basically what a spiral galaxy is, although this is a four-limbed one. It begins at first as a polarized object of sorts, whether you think it's a neutron star or a black hole, I don't really care. But it's not plasma, okay? Plasma does stuff like that by itself, okay? Yeah. So it begins with one magnetic field, creating the galactic jets emanating matter at the poles of the magnet, which, if it emanates matter like that, it also draws in matter at the dielectric plane, if that were to be happening, right? Now let's move on, and we see this. This is the galactic bubble that people see sometimes, and as you could kind of figure out, the polarity over here and over here are the same as this. Likewise, the polarity over here and over here are the same as this, which is why you could see a brighter line color over here, as well as the plane of inertia over there, which you could think about this as an analog for matter distribution of gas over a long period of time with a strong enough polarity right at the center of this, right? So this and this is equally going on at the same time. With this, right? This and this and this is happening at the same time. But there's also this right in the middle of this, and this. Well, not quite in the middle, but you kind of get what I mean. It's at the corner of the magnet, each and every corner. It acts like the top-down view of the galactic hourglass bubbles that you see sometimes online. And this geometry of incoherent spherical mass distributions of planets and stars in non-disc shaped galaxies. Some of them could actually be spiral galaxies, and we just don't know, just because we're looking at it at a different orientation that we're used to. But that's just a speculation that is worth contemplating about. And so before I finish this part of the video, I want you to think about this. There's 4 here, and flip over here, there's 4 here, and the center, there's 4, 3, and 4. Alright, so that means there's 12 limbs over here from the center part, emanating as one. And this magnetic setup itself is kind of curved inwards like that, like a hyperboloid, like that. Now, pause the video again. I have this geometry going on with this setup of magnets. Alright. That's what it looks like at the side. Profile, and then right there. So this one is magnetic south of the center. And the opposite side is also the magnetic side at the center. And this is a magnetic north at the center. Opposite side, magnetic north. Now, as you can see that for this magnetic north center, there's a magnetic north and there's a magnetic south divergence to the magnetic north cross. So there's a counter spatial magnetic north and a spatial magnetic south, and the inverse is for this. And I'll be combining these two. Voila. And now they're as one magnet. But look carefully. Look very carefully. Alright, you kind of studied what's going on. Anyways, but one part of this is basically functioning as it's a pseudo monopolar pseudo toroid, since it is in torus shape, but it is imperfect, as you can see. And it's a pseudo monopole because, well, there's different polarities at the corners in relation to the central cross. So a pseudo monopolar pseudo toroid, two of them together will have a pseudo dipole pseudo double torus or dual torus. That's a mouthful, really. So when people talk about the rolling coil and all that, you're basically seeing the outer magnetic field to be one, but the inner magnetic field to be the opposite of the outer magnetic field. But you don't measure the outer magnetic field unless you get inside the winding through the spaces of the rolling coil. Alright? So if you flatten a rolling coil, you also really make it closer to the dielectric plane, and you also make it much more powerful in that sense, for dielectrically powerful. And last but not least, I'll tell you how to program a disk magnet. the best way, which is to get a ring magnet and center the magnet with the inner diameter and the thickness of the ring magnet. Get two of them, put it together like this. So all right. Now just put it like that, and just slowly put it in. Like you want to slide in like that from the side, right? So this is how I will recommend to some people, because this is really dangerous and powerful magnets. This is also M52, 1.26 inch outer diameter, and the inner diameter is ½ inch. And the thickness is 1/4 inch. And if you do that, just leave the disc magnet inside a sandwich between them, you'll eventually get this. Now, whether or not the center part is polarized, I can't really say right now because I don't have the electrical pole finder. But I will say that this is fundamentally functions the same, just as a ring magnet with the center part filled in. They both have an inner bubble, as you could see. Yeah, both of them have an inner bubble. And of course it works on both sides. So yeah, that about concludes this video series, and I'll see you guys later.